Why do some engineers love model-based systems engineering? Because it gives them the blueprints to model their way to success without any delays. Okay, I think you get it, that this was a joke. So, therefore, let me state in this context that MBSE is very important, but it is not a sort of cookbook to success. However, the application of MBSE can provide some benefits to your organization, your development approach, and the developed system. MBSE can definitely bring your development approach to the next level. Let's consider a few of many benefits of using model-based systems engineering. It improves the collaboration with the customer and the developed team by working together with a system architecture model instead of several documents. So that's a very big benefit. A common understanding of the system by using a system model that merges the views of the different engineers. Then we have traceability and consistency by bringing all the information distributed to several documents into a system model. Another benefit would be the increased system maturity early by starting creating a system model early in the development. Then we have the reduction of development risk due to the intensive collaboration already early in the development process, so it's kind of connected to the benefit before. And then we have that's a pretty important point, the reuse options by copy and paste the model instead of rephrasing thousands of documents so that you can use it again for your future, maybe similar projects. And then we have, last but not least, the model-based documentation of the system and derivation of documents if required. By the example of model-based documentation traceability, think of a document-based approach in which a use case document and a system requirements document are created. So those two documents to start with. To allocate the entries of the use case document with the entries in the system requirements document, the IDs of the entries have to be linked. This can be done with creating additional columns in both documents and insert the relevant IDs, or by creating a traceability matrix with a further document that links those IDs, which you can see here. So the development of a system does not end with only these two documents. I think you know that. There are further documents created such as subsystem requirements documents, function specification documents, and an interface specification document, for example. Those are just an example for you to get an idea. The entries of these documents should, of course, be allocated to other entries in other documents too. So this is done once again with traceability matrix documents. Without such traceability matrix documents, changes of entries in documents are very costly and time-consuming. Managing all these documents in the development process requires a lot of time, resources, and can lead to many errors. A solution for that is the use of a system model in the context of model-based systems engineering. The information text-based documents contain are modeled in form of a system architecture model, which we mentioned before. In the system model, all the entries of the document are modeled in form of artifacts, such as use cases, requirements, and so on, and connected if required. By the use of semi-formalized and formalized modeling languages, the model can be queried. So this means in case of changing, for example, a function, which happens a lot, the modeler also knows which other functions, which structural elements, requirements, or use cases should be considered as well. Think about the engineers that have to work with all the different documents, manage the content of the documents, and keep the overview of the system while developing the system. That's a huge task. And now think about the same engineers that use model-based systems engineering in form of a system architecture model. all the information that is normally distributed to several documents is now merged into a queryable system model. Failures and risks are identified faster, can be eliminated, hopefully, and due to the better overview of the system and the better collaboration possibilities, the system maturity as a whole is increased dramatically. From a psychological point of view, working with documents all day can be monotonous and tedious. Working with models instead can be exciting and motivating, since our brain is better working with visual representations instead of texts. But that's just a side note and a side benefit. Now I want to shortly discuss one of the biggest benefits, in my opinion, of MBSE. Models in general have a better reusability. They are faster understandable, well adaptable, and contain already a lot of information. Reusing documents for a new project means that all the existing documents from the previous projects have to be checked, read through, and understood again. Then some of the documents are copied to the new project, some texts have to be rephrased, and when entries between some documents have to be linked or checked, the chaos starts again. Models. System models, on the other hand, contain all the information that is typically distributed to several documents. When reused, the model is also copied or shared or derived, or how you need it, to the new project, and an engineer, of course, has to recheck the content, make necessary adaptations and extensions, but this is way faster and simpler. This only works well, of course, when the model was well created, but this is also for the documents the case. By the example of a system architecture model of the DQ400E, the development of the next generation transmission named, in this case, DQ400E2, the architecture is copied and adapted. This means the structural description, including the interfaces and relations, the behavioral description, the traces to requirements, and many more, are copied and reused for the next generation project. For the next generation, for example, a further sensor is mounted on the clutch C0 to improve the interaction between the combustion engine and the transmission. Besides the adaptations of the structure and further control functions, the main parts of the transmission are reused, which means time and cost savings, as well as reusing already existing knowledge in an effective way.